Hi folks, in this session we're going to be covering key characteristics of ellipses and just covering some of the general equations and how to draw them. Okay, let's get started. An ellipse generally can be defined by taking a point P on the circle and adding the distance between F1 and P with F2 and P, which should give a constant. Now, if you take P along, that's generally the idea, and if you take P along anywhere around that red circle, it'll always be the same distance. So in other words, if I take PF1 plus PF2, that should equal a constant. So if I was to try that in another circle, another ellipse, as you can see, no matter where P goes on that on the red path of the ellipse, the distance between F1P plus F2P will always be the same. And that's what defines an ellipse. Now, the 2 points F1 and F2, these 2 points are called the foci of the ellipse. Also, there are 2 lines of symmetry in this ellipse, one on the horizontal axis and one on the vertical axis. And finally, the general equation of an ellipse is a little similar to the circle, but with some variations. X squared over A squared plus Y squared over B squared is equal to 1. This is the general equation of an ellipse. Now in the next slide I'll be going into more details, just so you get the hang of this equation. So here we are, a ellipse has already been sketched here. I've got x squared over a squared plus y squared over b squared equals 1. So the a is, you're going to have this particular value is going to be positive a, while on the other side of the ellipse, that's going to be negative a. And as for the b, yep, you guessed it, it's right at the top there, that's the y-intercept for positive b, and that would be minus b at the bottom. So basically, a and b, they actually give the intercepts on the x and y axis. The next thing is looking at the foci, positive c and minus c. So basically, C0 and negative C0 are the 2 foci points. Now you might wonder what the relationship between, how do I know that C is actually there? Well, the relationship for C, B, and A is quite simple. It's actually C squared is equal to A squared minus B squared. Now, I know this might seem like an information overload, but believe me, after a few practice runs, you'll get the hang of this. There's one more thing, a couple of more things you need to remember. One is that there is a major axis. Now the major axis is from wherever negative a to a is, and so it'll have a length of 2a. Now I've drawn it here in purple on the graph, as you can see. Alright, of course the other one, you can kind of predict it, but minor axis, this is obviously from minus b to b. It has a length of 2b, and of course I've drawn that in green right now. So these are some of the major things you need to know about an ellipse. Okay, moving on to the next slide. There are cases when you can get where b is actually greater than a. Most of the time you'll end up with a bigger than b, but on the occasional odd times you will end up with b greater than a. And when you end up with that, it's simply the ellipse is just, well, as you can see, because b is actually bigger than a, the ellipse is a lot more skinnier, I guess you could call it. Yeah. And now for the last thing, guys. This is called eccentricity. Now, what is eccentricity? It's basically looking at the ratio between C and A. All right. Now, there could only be 2 situations that can happen. One, where C is similar to A, or 2, C is very small compared to A. Now when C is similar to A, you will end up with an ellipse that's looking really flat. But when you have C is very small, when C is really small compared to A, you end up with more of a circle really. That's because if C is very small compared to A, then the two foci points are a lot closer. And as you can see, if it's really small, then it almost becomes into a circle. Now if I go back to C is similar to A here, on the left hand side, you'll notice that the blue dots are a lot closer towards A. And that's pretty much that I can think of for ellipses at this point. Some of the most important things you need to know. Alright guys, that's it for this session. Thanks for watching.